Determine if the following series converges or diverges. For this exercise, we're going to use the integral test. Here's the integral test. Suppose f is a positive, continuous, and decreasing function on the interval from n to infinity. Then the infinite series here converges to a real number if and only if the integral below is finite. So basically, if f satisfies these three conditions, positive, continuous, and decreasing, then to test whether this infinite series converges or not, we just need to look at the integral here. So let's look at the first question, the summation, 1 over 5n plus 3. So let fx equals 1 over 5x plus 3. And let's first check whether the three conditions are met here. So positive, of course, is positive when x is greater than 1, greater than or equal to 1. It's continuous, and whether it's decreasing, it's obviously decreasing. So we can use the integral test. So all we have to do is to look at the integral here. So let's look at the integral from 1 to infinity, fx d of x, this is equal to integral 1 from infinity to infinity, d of x divided by 5x plus 3, this is equal to 1 to infinity, 1 over 5 d of 5x plus 3 divided by 5x plus 3. So here, d of 5x plus 3 is equal to 5d of x. That's why dx is equal to this whole item. So this is equal to 1 over 5 log 5x plus 3 from 1 to infinity. When x tends to infinity, this item is infinity. When x is equal to 1, this is a constant. So this whole item is equal to infinity. Okay, so by the integral test, now we can tell that the summation of f of n is diverges. So basically, we conclude the 1 diverges based on the integral test. Let's look at the second question. Let fx equals x squared divided by x cubed plus 1. When x is greater than or equal to 1, it's positive, obviously. It's continuous. Now let's figure out whether it's decreasing. It's not very obvious here. So to figure out whether it's decreasing, let's look at the derivative of fx. This is equal to, by the quotient rule, x cubed plus 1 squared, x squared prime times x cubed plus 1 minus x squared times x cubed plus 1 prime. So this is equal to x cubed plus 1 squared x 2 minus x cubed. Now, this is less than 0 when x is in the interval from 2 to infinity. So basically, when x is greater than 2, this whole item is less than 0. So when x is on the interval from 2 to infinity, so which implies that fx is decreasing on this interval. So now we have fx is positive, continuous, and decreasing on this interval from 2 to infinity. Now, to figure out whether this sequence converges or not, this series converges or not, we just need to look at the integral here. So basically, we have to look at the integral from 2 to infinity. Fx is x squared d of x divided by x cubed plus 1. So this is equal to 2 to infinity, 1 over 3 d of x cubed plus 1 divided by x cubed plus 1. This is because this item is basically 3x squared d of x. So basically, x squared dx is equal to 1 over 3 dx cubed plus 1, because this thing is just a 3x squared d of x. So this is equal to 1 over 3 log x cubed plus 1 2 to infinity. Again, when x tends to infinity, this is infinity. When x is equal to 2, this is a constant, so this is equal to infinity. So by the integral rule, the integral test here, we can conclude that the summation n equals 2 to infinity n squared divided by n cubed plus 1 diverges. Now, when you look at the original series, the summation is from n equals 1 to infinity. So, but this is from 2. So there's one actual item, but it doesn't really matter. So this, you can write this as the first item, 1 squared divided by 1 cubed plus 1 plus n equals to infinity, n squared divided by n cubed plus 1. And we showed that this second item diverges, and the first item is a constant. So the whole summation, or the whole infinite series, it diverges. So basically, we conclude that 2 diverges. Okay, thank you for watching.